in this video, I'm going to show you how to visualize big vector data in Python really fast and easy. If you have ever used Python to visualize a vector data set, you know it can be quite frustrating, especially if your vector data is becoming quite large, for example, hundreds of megabytes or gigabyte, and if it has millions of records, you will struggle. And that up until now, there's no easy way unless you convert the vector data to other data format, for example, PM tiles, or maybe use desktop.js to open the data. But this new functionality that I added to Leafmap will make your life so much easier, so you can do everything just within the browser using Jupyter Notebook, and you can visualize whatever vector data format you like. So for example, here I want to show you what we're going to do later. This shows you the building dataset covering the entire state of Alaska, and it has over 200,000 buildings. We can visualize them so easily within Python. So you can see I can zoom in and can zoom out very easy, and your browser is not like crashing, and you can see all the building here. Nice thing, you can even change the visualization. This right now here, it shows well and just a typo, but you get the idea. You can change the color if you want to. Okay, you can change the opacity if you want to. So it's very simple and easy, very responsive, super cool. So this is kind of a build on top of the recent DuckDB functionality that are serving vector tiles. And I integrate this one into Leafmap to make it really easy. So you just need one line of code. You can visualize any vector data set you want really easy. It took me many hours just to implement this one so that it supports a variety of data formats, and also it works in Google Colab, your local Jupyter, and also remote JupyterHub. Very useful, and let's dive into it. So first, you need to go to the Leafmap website to download the notebook examples. Once you're on leafmap.org, click the map library, scroll down to find DuckDB layer here. So just click DuckDB layer, and then it should open the notebook. You can either run this one in Google Colab here, or you can download this one to your computer. You will need to install the latest Leafmap DuckDB version. So you need version 1.4.1. If you install Gmap, upgrade Gmap, you update that to the latest version. Then you can open that one in JupyterLab or Google Colab. So let me restart the kernel and then show you from scratch how we're going to visualize the vector data. I'm going to show you 3 examples. You can visualize the data, GeoParquet data, and then create a temporary database, or you can visualize data in an existing database. Also, you can visualize data either locally or you can visualize data in the cloud. Either one should work. So let me show you. I'm going to here import the libraries. So I'm going to import the map library backend, and then you can download some sample data. One thing I would like to point out here is that if you're using a remote JupyterHub, that means you are using a JupyterLab on a remote server. Then you will need to set this one, uncomment this one. Make sure you change the this kind of domain to your JupyterHub domain. If you're running it locally, you don't need this one. So I just want to point it out because it's quite common. People are trying to do everything in the cloud. And so once you set this one, you are good to go. Next, we can download some sample data. So I have some sample data hosted on source co-op. If you want, you can click the link, take you to the website here. These are some of the wetlands dataset that I processed and uploaded there previously. So you can see these are all the vector dataset, pretty big, like gigabytes data to hundreds of megabytes. And previously, you cannot just easily visualize this one in Python. You have to use desktop.js, or you need to convert to PM tiles in order to visualize them in Python. But now you don't have to. You can just download the data, or later I'm going to show you like you can also pull the data from the cloud that you can visualize without having to download them. Once we have the data, now we can just create a map. So as you can see, these are all the kind of same step. You create a map, and then you can add a base map. Before I did this one, basically means you want the label on top so that you can have the imagery, you can have the label on top of the imagery. This is just the line that you need to utilize to visualize vector dataset, any vector dataset. So earlier when we downloaded the Rhode Island wetlands dataset, the Parquet file, we saved this one to the local computer. It's on our local computer. If you click here, you will be able to see this one here. And just use this DuckDB layer, specify the data input, give a layer name. So the layer name is what you want to choose for the data layer to show up on the layer manager. You can also customize it, whether it's a line or polygon. So for polygon, we're going to use the fill layer type, and we want to utilize the color, for example, light blue color, opacity 0.5. Whether or not you want to fit bounds means you want to zoom to the layer extent. Use view. This one, if you're using it locally, usually you want to set X false because you can copy the data pretty quickly. So it's going to under the hood converting your data into a DuckDB database only takes a second or two, then you'll be good to go. But if you're using remote dataset, you'll be passing, for example, HTTP or H3 bucket, then you might want to change this one to true. That means it doesn't have to copy the entire dataset. This can be helpful if your dataset is very big, like gigabyte data. It's going to take some time to transport the data to your local computer. So you want to actually make sure you use this one to false. Also, the min zoom is when you're zooming and zoom out, it's going to basically query the extent and then show you the data. Sometimes if your data is like tens of gigabytes, hundreds of gigabytes, you want to set the minimum zoom level so that it doesn't need to filter the data for a large area. So just for small area, you'll be so much faster. And these are some of the key parameters you certainly want to set. Later, I'll show you an example how to use that. So for now, let's just run this one. And it's going to show you some basically the logs in here. This is pretty normal. It's going to show you what it's doing. If you don't want them, you can just set quiet to true. Then it will not show you any of this. Okay, so now it's done, right? So we have all the wetlands for Rhode Island just easily. So you can see zoom in, zoom out really quickly. Sometimes you will see some of the big bounding box. That's normal. It basically DuckDB construct the vector tile. So I'm going to show you. If you zoom in, you will see more details of those, and you can click your mouse on any features. It's going to basically query them and then show you the tooltips. Very, very helpful. Like I said, you can use it to visualize any data set very, very fast. And I don't have to manually convert to other data format. You just one line of code and then get the work done. Under the hood, this is basically running a DuckDB tile server, vector tile server. If you click, it will take you to basically the website showing you here the tile endpoint, blah, blah. So you don't really have to worry about that. It's all have been taken care of under the hood. You can also see this one here. So every time when you are zooming and zoom out, it's basically going to query based on your zoom level and the X and Y. Also, you can see how many features. So for this one, we have 55,000 features in this data set. Later, I'm going to show you like to visualize data set with millions of records easily. You can do the same thing. It doesn't, the workflow is the same. And one nice thing about this is you can change the color easily. Click the floating icon here in the upper left corner. Here, you can change the opacity. And everything is very dynamic. It's not just for the entire area. So I can change, see here. You can click the settings icon. So for here, I can change it to any color. For example, change maybe to red color. And then just click apply. Oops, maybe change the opacity to a little bit larger. All right. So it's super cool, super powerful. And you don't need dataset.js. You can do everything just using the browser. You can do data analytics. Then you can visualize the data. You can visualize data first. Then you run the analytics. So you can run everything in the cloud now. You can visualize. So for raster dataset, we have already supported using cloud optimized GeoTIFF. But for vector dataset, we haven't really been able to do that up until this point. Now we have the solution for visualizing all kind of vector data. So this is one example for visualizing data for what's this one for wetlands. But I can show you another one for visualizing building dataset. So this is a building dataset covering the state of Alaska. And let me see how big this one is. 100 megabytes. It's not too big, but because it's compressed. So we can either visualize the GeoParquet file or you can use visualizing the GeoPackage. Either one is fine, it doesn't matter. It's going to basically convert it for you. And so let me change the layer name to buildings, okay? Other than that, it's all the same. So let me just run this one and you see how fast it is. So a couple seconds, now the map has been created. One thing you did notice here is that it zoomed to here. It's kind of very weird because there's a kind of a building here in Hawaii. I don't know why. So there's kind of the typo, but if you zoom in to the state of Alaska here, let's look at Anchorage and take a look, right? So for this building dataset, it has 200,000 buildings. It's a pretty big dataset, but we can visualize them without any problem, super fast and easy. Also, change the building opacity, change the color as well. Oops. And change the rate. And then here. All right. So try it out. Very excited about this new feature. Took me many hours, and finally I was able to figure it out. And I hope it's going to make your geospatial workflow so much easier. So this is for Alaska. I actually also downloaded it for Florida. So for Florida, this one, this is a GeoPackage file. So it's 4 gigabytes. Let's see if it works. I haven't tried this dataset. Sometimes some of the dataset doesn't work. It can be the projection. It can be some like stuff that's not incompatible in the GeoPackage. It might not work. So let's give it a try. And so I'm going to visualize this GeoPackage and same step. Let's see if it works. Maybe we should set a zoom level, a minimum zoom level to maybe 12 or something, because this one is much larger. So when you zoom out, it's going to query the data. Sometimes it might use a lot of memory. So set this one to maybe to a larger number. See, so that when you zoom out, you don't query the data. So it will save your memory. So run this one and let's wait, see if it works. So under the hood, it's going to automatically convert the data, basically do the map projection, because the dataset is in WGS84. And in order to serve the vector tile, it needs to be web Mercator. So it'll be 3857. So this one sometimes might be a little bit slow. If you're using, okay, it's not too bad. It's done. And okay. Again, you have some weird stuff here. Zooming to, yeah, this is in Florida. Let me zoom in, see if it works. If it doesn't work, sometimes might be some like invalid data in the dataset. I might need to look into that. Oh, is it working? So here, no, it actually works. Here, right? You can see the buildings, all the buildings here. So if I click the building, yeah, something is weird. I'm not sure. It might be the, oh, this one is the 3D building, not the. Let me turn off the building data layer. Oh, it's the background, not this one. Oh, yeah. All right. Yeah, not sure why it's not showing up. Like I said, there still need more testing, because some of the data say if they have some invalid stuff in there, it might cause some of the issues. I might need to look into that. Errors. Yeah, let me look into that. So, but under the hood here, you see it's actually querying the data. Most of them should work. Anyway, I will look into that later. So this is how you can visualize large vector data set. So let me switch to maybe Alaska and then Parquet. If you try your data set, if it doesn't work, feel free to open a new issue on GitHub. I will look into that to see, because right now it's doing all kind of data conversion under the hood. Sometimes the data is not being converted correctly. It might not show up. Okay, this one still works. So this is for visualizing data, any vector data format, and then convert it to a database under the hood. But you can also load existing data. If you already have a DuckDB database, so here, I'm going to download a sample NYC database from GitHub. And this one is downloaded here to my computer. You will see here DuckDB. So this is a DuckDB file extension. Next, we're going to do the same thing. We're going to create a map and then use the DuckDB layer. Different from the previous one, that you need to specify data. This one, we're going to specify the database path instead of data. So database path means you're going to point to an existing database. And then, so this is the one, the file name here. You will need to have the table name. So inside the DuckDB, if you already know the table name, then you can just point it to this particular table name inside, and then you can specify you want to visualize as polygon or as line or something like that. One thing I want to point out here is the src CIS. So sometimes some of the data in the early DuckDB versions, it cannot really store the coordinate information. So in that case, the data might not be plotted correctly on the map. So you want to, if you already know the projection, you want to specify here. So for this one, I know it's UTM projection 26918. If you don't specify it for this one, then if you try to visualize the map, although you have the database, it might not be plotted to the correct location. Oh, actually this one is yes. So let me show here. Fit bounds to true. You probably zoom to a different location because the data is not being plotted on the correct one. You see, right now it's being plotted in the middle of the ocean. This is certainly incorrect. So I created this database a while ago. At the time, the spatial extension doesn't support kind of storing information. So you can manually specify the fit bounds. And so now if you run again, you see, it will be able to zoom to this one correctly. So it's so much better. Going to save you some time. But certainly there are some tricks right now you might need to pay attention to. Otherwise, you will, okay, why the data is not plotted in the correct location. So this one is relatively small, but you get the idea. It doesn't matter. If your data is already in the database, then you can also use this way without having to copy the data again. And let me show you here. I can zoom in, I can zoom out. I can change the opacity. I can change the color as well. Everything is very responsive, so it doesn't take too much time. Just click apply, then you are good to go. Apply. So this is how you can visualize an existing database. So next, let me also show you another example that, oh, maybe you want to visualize data from the cloud. You don't want to download them, then we can do that as well. So if you go to the maybe the National Wetlands data, the source cooperative, right? So earlier I saw maybe this one like Rhode Island dataset, 69 gigabyte, right? So this is the URL. You can also use the S3 bucket, I believe. So I can just maybe copy this URL and then come back to here. So let me go back to the previous example. I'm going to do it from here. So for the data, instead of the local file path, I can right now convert this one to an S3 bucket file path. So you can just replace here, and then what you need to change is you can certainly use view to force them. It's going to copy the data, so it's going to download the data and then visualize them. But we can also say, okay, use view equal to true, and then maybe zoom level minimum. How about maybe 10? Okay, we can change it later. Maybe 8. Okay. Use view, that means just going to just use DuckDB to query the data without copying, to create a view instead of create a table. And then fit bounds maybe set to 2, and everything else, let's just give it as default, see if it works. This is going to take a little bit longer because it's passing all the data through the internet. So DuckDB, although you don't need to download the entire data set, but DuckDB still need to actually query some data in order to show you, for example, the geometry column. But it should work. All right, so now we have this data set. Okay, back request not fine. Oh, the correct. Oh, okay, this one probably is a bug. I might need to fix it. I think under the in the code I need to maybe expose the parameter. Anyway, so let me change to the other one. How about this? I copy the HTTP URL. This is a good things to try. I need to fix it. Okay, so hopefully it's not taking too long. Certainly for the HTTP, it should have relatively similar performance compared to the S3 bucket. But the advantage of using the S3 bucket is you can pull multiple data sets together if you want. So you can have a star and then dot packet. So you're going to pull basically all the data under the folder rather than having to do it individually. Okay, so it's done, and let's see if it works. So I need to zoom in because we set the zoom level to a much higher one. And let me turn this one off. So this one will be a little bit slow because it's based on zoom level. It's going to query. It might take some time to load up. Let me see here. It's definitely not instant because the data is still in the cloud. It's querying and then serving the tiles. So it might take some time to load up. If it doesn't work, then you click the developer tool and then see here, sometimes you want to see the error. Right now, there's no error, so you can be zooming and zoom out. Let's see here. Yeah, it looks like it's working. Well, I'm not sure why it's not coming. When I was testing it earlier, it was working, but it just take a little bit longer to show up. So I would recommend is usually if you can, download the data locally. This is not a fully cloud native solution because for the cloud GeoParquet file, the data is still in the cloud. So if you want to visualize them, you still need to pass back and forth from your local computer to the internet. And see here. All right, something's weird. It may not work. I think when I was debugging, it was working, but if it doesn't, then I need to look into that. So I also fixed the S3 bucket. But this is still just the preliminary version. You're welcome to try it out and give feedback. If it doesn't work, open an issue on GitHub. I'm happy to look into that. And I hope this will be the new way that you can use to visualize a large vector data set, especially if the data is already on a local computer. It's going to be super, super fast. Okay, that's all. I hope to see you in the next one. Take care.